What's the answer for the first one? The laboratory apparatus. So, which of these are needed to collect pure water from seawater? One, yeah. You don't need the burette, you don't need the filter funnel. Okay, when do you use number two and when do you use number three?
Number 3 is titration.
Yeah, so then number two is
Filtration.
So pure water and seawater, there's no solid to filter, so you don't use two. Then titration process, you are adding a solution to another solution. You need accurate measurement of the amount of chemical to add in. So we don't have that in the process of separating pure water from seawater. So two and three don't need two. So what deductions can be made about the properties of the two gases? So you have two methods here. How this one works, right, is like this. You pass gas inside, the gas comes in, then after that the gas will sink. Then what it does, because inside originally there's air, so the gas goes in, then air will get pushed out. So for this setup to work, your gas must be denser than air, because less dense will float, then more dense will sink. So the number one gas, right, should be denser than air. So gone. Did you catch that?
Yeah.
Okay. So then, right, you got the gas number two. What you see is you pass gas two, right, into water, goes through water. If the gas is soluble in water, right, all the gas will dissolve in the water. But this setup, right, your gas number two gets collected up here.
I mean, it is soluble in water.
It is not soluble in water.
It's egg.
Yeah. If the gas is soluble in water, right, all the gas
Then
will
it will
stick
dissolve.
inside. Yeah, dissolve. Then you won't get this empty space. Okay.
Yeah.
Three experimental processes are listed. Then you obtain water from sodium chloride solution. Then obtaining solid sodium chloride from sodium chloride solution. Then you have the third one, which is obtaining sodium chloride from a mixture of iodine and sodium chloride. Then they ask you which methods will you use. Okay, number one, distillation. Okay, obtaining solid from, okay, number one is fine. So you are down to this two or gone. You use filtration when there's one solid that's insoluble in solution or insoluble in whatever that you are given. So sodium chloride is soluble in water. Then if that's the case, right, you will not be able to get solid sodium chloride from sodium chloride, right? So solid sodium chloride from the solution, because what you see is just a normal solution. Okay, if we do filtration, you pour the water, the solution inside here, then all will drip out and then look the same. And then the sodium chloride particles, right, will not be caught here. It is soluble. You won't be caught there. You won't be caught by the filter at all. You know what I'm saying?
Yeah.
So which means this one out. Then of course, because this is an MCQ question, you see that all B, C, and D options are out, then your answer straight away is A. But of course, I have to explain why it's evaporation and why is it sublimation. So because this is, okay, so we go to point two again. So this is a solution. Then there are two ways to get crystals from here. One is, not say crystals, but maybe solid sodium chloride. So one is via crystallization. The second way is to evaporate. So if you evaporate, I put this in the evaporating dish, then this is a solution. Heat. All the water will be expelled and then you'll be left with the salt under. So you use evaporation is okay. Then NaCl is stable to heating. What does stable to heat means?
Oh no.
Okay, so that means if you heat, right, certain things like sugar, once you heat it for extended period of time, you will see that the sugar from white becomes brown. You know that? So if that happens, right, we say that the sugar has decomposed because of the heat. So sodium chloride, if you heat it, it will just stay the same. Water gets expelled and sodium chloride will remain white and it doesn't change. So we say that the sodium chloride is stable to heat and then the sugar is unstable to heat. Sugar will decompose, sodium chloride will not. So it will remain as sodium chloride. So that's stable to heat. And then lastly, you have sodium chloride and iodine. Iodine is something that will sublime. Sublime means it turns from solid to gas directly. So what we usually do, right, is we'll put an inverted filter funnel, then your solid here with sodium chloride and iodine, the mixture. Iodine is black here, purplish black. So then you heat this mixture. When you heat this mixture, iodine will sublime, so it becomes iodine vapor and it will come out. Then after it comes out, right, it will then cool down on the cool surface here of the filter funnel. Then it will collect on top here. So once you heat it for extended period of time, all the iodine will sublime and then gets collected on top here. Then you can take out the filter funnel and then scrape off the iodine. So this is via sublimation. So answer is 8. Okay, do you need to take notes?
What is sublimation?
Okay, so let's come to this, right? Like I told you earlier, right, your teacher can ask you, can continue to use this question, because when I was explaining to you, I told you, right, that there's two ways to do an MCQ. One is you pick the best question, best answer, then or the
Elimination.
yes, by elimination. Then if you notice just now when I was doing, I wasn't even going through the sublimation, but I just went to, I said that this one, this question, this section 2, right? This section 2, you cannot use filtration. Then at that juncture, because we already eliminate this and this. So by looking at filtration, I know that this is not working out. So this is wrong. So this gets eliminated. Then naturally your answer will be A already. So you could get the correct answer even if you did not know sublimation.
But I don't need to know what is sublimation in order for them to test this question.
No, that means, right, you don't need to know sublimation. Even if you don't know sublimation, you still can get the answer.
Means if teacher tests this question, it's an elimination.
Yes, you can eliminate directly. But of course, I'm going to tell you what sublimation is now, in case you see this shit again and it appears in some structured question and then you have no way to wriggle out of it because someone did not really exactly go into detail on this. Okay, so let's do it. I'm going to reduce this and make some space for myself. First, then make space, then I have a place to write. Okay, so just now I was talking about sublimation, then you say, what is sublimation? Sure, never heard of. So remember the change of states from solid, liquid, gases, these three things.
I think teacher went through it briefly. Like teacher went through it like it's when gas changed to a solid.
So there's this solid to liquid, you call it melting,
then
boiling, and then this sublimation.
Sublimation.
Like some point of time you would see this. I think in primary school they also mentioned this word called sublimation, but whether they go into detail or not, that's another thing. So we got this.
I think the teacher just said sublimation is when a solid change to a liquid. Change to a gas. That's all.
Change to a gas. Yeah. So this is the basis of whatever you did on question 3, that sublimation. So this sublimation is a change of state, the process where it change state, right? It can also be used to separate two substances. There are substances, chemicals that will undergo sublimation. One is iodine, the most common one, the not so common one I cannot remember. So I'll just list them, but I think I will later do in detail about this one. Okay, so there is iodine and
solid to change to a gas, it needs to change to a liquid first, then to a gas.
But substances that sublime, right, it will straight away bypass the liquid state. It doesn't change to liquid at all.
Means can it still change to a liquid?
You would probably need to meddle with the external conditions.
Means it can still change to a liquid.
If you want to get a liquid state, you may need some extra processes, which is not within our scope at this point of time.
Which is not in the syllabus.
Yeah, it's not in the syllabus. So it's easier for these substances to sublime, to change directly to gas than to make it become a liquid form. But of course, you can do some other things like dissolving it in a solvent, etc. Those can get it into a somewhat liquidy state, but it equals, or you dissolve in alcohol, that's possible. Then if you want straight away change it to molten state, we need to examine something else, okay, which is not in our scope right now. So these two substances, and probably there are more, these are the substances that sublime, okay? So when you go to the topic of separation techniques, then they say you have solid A and solid B. Then you want to separate solid A and solid B. So if the usual case when we have two solids, right, like let's say sand and salt and NaCl, you would say that you dissolve in water, then NaCl goes into solution, right? Then sand will be insoluble. Your usual case, like if they say two solids, then you want to separate the two solids, you will say you dissolve in water, then one of them dissolve in solution, then the other one is insoluble, then you do filtration. Then after that, then you do crystallization for the filtrate, right? Something like that, right?
Yeah.
Then after that, you take the sand and you wash with water. Then after that, then you dry it, etc., etc. So when the two solids, right, that were given to you, one of them contains either iodine or an ammonium salt, right?
Yeah.
Then this below here does not work. It immediately straight away, right, becomes sublimation because one of the substance will sublime. Then how you do sublimation? Okay, so you got the sand and sodium chloride already, right? I can delete that portion, right?
Yeah.
Okay, so in that case, now we change to say iodine. So iodine sublime. So if I heat iodine, okay, let's examine iodine on its own. So I have a solid iodine. Then I heat. What happened is it does not become liquid state. It undergoes sublimation.
It becomes a gas.
It becomes a gas. So then you become iodine vapor. So you see purple fumes, literally. If it sublimes, you'll see purple fumes. Okay. Then you know that if you have a gas, you can always do condensation or whatnot. Then the solid will not the gas will be condensed back to liquid state, right? Like you have water vapor, you will put a water vapor here. Then you want to collect the water, you will put a cool surface. Then the water vapor touch the cool surface, then it will condense and then become water droplet again, right? Then after that, it will drip off, right?
Yeah.
So if you want to, for this iodine, right, if you want to collect the solid back again, right, from the iodine vapor, right, you do the same thing. You will put a cool surface. Iodine vapor will come to here, and then it will change back to its original state. So water, because it comes back to liquid state, it becomes water droplets. Iodine, because it sublimes, it was a solid and then it goes to gas, it will come back as solid state. So iodine solid here. So that's how you collect the iodine solid again. If you have iodine alone, okay? Then now, right, let's go back to it. So now, instead of, iodine alone, you will have a setup where you will have solid NaCl mixed with the purple color as iodine, like that. So you will heat this substance again. Then what happens? What would you expect if you heat the mixture? Iodine and sodium chloride. Sodium chloride is salt. If it's in solid state, when you heat it, nothing should happen. It will still look the same because it is stable to heat. Then what will happen to the iodine?
Is that iodine is in solid?
Yes, in solid too.
Then it will become a gas.
Yes, it will become a gas. So iodine will become vapor, right?
Yeah.
Then your job right now is to separate iodine and sodium chloride. So you want to end up with two containers, one containing salt iodine, the other one contains sodium chloride. So you will have to find a way to capture the vapor. You want to capture the vapor. So you want to collect this vapor. So what you do is you put a inverted filter funnel. So the inverted filter funnel acts like the cool surface that I was talking about just now.
What's an inverted filter funnel?
Yeah, because in the surface of the filter funnel will be colder than the surroundings. But do you all still use filter funnels? When I was studying, my filter funnel is made of glass. That means the surface is cool. The surface is cooler than the iodine vapor. So when I invert it, right, this is a cool surface. So the iodine vapor will touch the cool surface and have this effect, this cooling, condensation, solidification effect.
It's an inverted filter funnel, just a filter funnel turned upside down.
Yes, it is. Your whole purpose is to just provide a cool surface. But some other setup, they can use some other thing as long as they can close up the top of the evaporating dish and provide a cool surface, it will still work out. So some can
like a metal lid.
Yeah, some can use metal lids and all that as long as you allow the air inside to escape. Because if you don't let the air inside escape, you'll build up air, you will build up pressure inside and you will cause another problem. So once you have this inverted filter funnel, you keep on heating until no more vapor forms, right? Then you can take out the inverted filter funnel and scrape off all the iodine solid that is on the funnel. Then you would, whatever that remains inside the evaporating dish, right, will be sodium chloride. So you will have one container of sodium chloride, the other container with iodine. This is the sublimation process for separation techniques, not the change of state. Number 4. Okay, why is it 3? Is the standard answer 3?
Red dyes in each, because there is a different red dye in each.
Okay, so you want to know the difference, right? Is dependent on the RF value of the dot. So it's basically
What's RF?
Okay, let's not talk about RF, but you measure the distance of the dot from the starting line. So the starting line is here. So you see a red dot, you measure the distance.
Means that is 2.
So you measure the distance, right? If let's say this is 2 centimeters and this is also 2 centimeters, right? That means these 2 red dots are the same dye.
Does that mean there's only 2 different dyes?
Yes, I think there's only 2. Then this one, you measure from the starting line, maybe say it's 8 centimeters. Say this one is also 8 centimeters, then they are the same. So these 2 dots are also the same dot. That means they are the same dye. Then, of course, if you have another red dye here, let's say here, another red here.
Then that will be 3.
Yeah, because this red dye is not the same as any or other red dye. The distance is different. So then this will be another one. But now I think the answer only 2. Okay?
Yeah.
Okay, which substances will have particles closely packed to each other? Okay. Closely packed to each other, solids, possible liquids? I don't know. Let's look at the question because particles, right, in solid state, the particles are super close to each other. Then liquid state, right, the particles are also close together, but not as close as solid. Then the only one that has the particles are far away from each other are gases. So P, melting point, room temperature and pressure. So this is a gas. Alright, then room temperature and pressure, this is also a gas. Then R is a liquid, then this is a solid. So answer, only R and S. You don't have Q. The options with R and S, the other one is D. But D has Q. Q is a gas. So that one automatically goes out the window. Your answer is correct. These 2. Back to the old symbols again. Which statements about the 2 atoms are correct? So in your case, P, then A, then this one is, so this is let's not call it Z. Okay, let's put XY. Then the big number is the atomic mass, and then the small number is the proton number. Agreeable with that?
Yeah.
The big one is atomic mass or your mass number. So I looked up the periodic table and 27 is the proton number. So I go to 27. Proton number 27 is cobalt. So the 2 atoms are both aluminium atoms. This one out. So it's B because they have different mass numbers. The 2 atoms have the same mass number. This one is wrong. They have the same proton number. Then because the atomic mass is different, the number of neutrons will be different. Answer B. Okay, 7. I mean, I have gone through. So relative charge is okay. Then relative mass is 0. Relative charge is 0. Relative mass is not A. No, relative mass is not 0. 0 means it doesn't exist. Not 8. The charge answer should be B because relative mass is 0. If relative mass is 0, then there's no mass, then it's not even a dot. So I cancel out This is not 0. So relative charge is correct because it's negative charge. Neutrons are neutral, so they got no charge, 0. Then the mass, right, is 1. The neutron and proton has the same relative mass and is bigger than the electron. So this one out. So this one with the charge 0, and this one is bullshit because there's no such charge in our textbooks or in whatever we learn. We don't see electrons with this kind of charge. So C and D out. So relative charge is -1, and then it is super small, 1/1840. Then neutron has 0 charge and the mass is 1. So answer is B. And this is a textbook question. If you are wrong, then something is very wrong. It's a question where you can get the answer straight off from the textbook. Go to the next one. Well, bonding. So you get X3 plus O2 minus. So it loses 3 electrons. Next one. How many pairs of electrons? And it's shared number of pairs. So this is 1 pair, this is 2 pairs, this is 3 pairs, this is 4 pairs, and then 1, 2, 3, 4, 5, 6 like that. If you're missing out on keywords, right, like you miss out reading, I think then you should read as you go. You circle the important keywords. If not, you lose marks for nothing. So V has 1 electron, 1 valence electron. So 1, 2, 3, 4, 5, 6. So W has 6 valence electrons. So V, then noble gas is out immediately. Then A is out because this has 7 valence. Then this has 1 valence and this has 6 valence. And then this has 1 valence and 1, and this has 6 also. Why did you choose C and not D? Why C and not D? Because both have 1 electron and 6 electrons. Okay, remember covalent and ionic bonding. Covalent bonding happens between
non
they share electrons. Then so it happens between usually non-metal and non-metal.
And then there's a metal and a non-metal.
Then that one's ionic. So when it's ionic, the dot and cross diagram shouldn't look like this. That's why it's not D and it's C. Okay?
Yeah.
Wow, this one you should know how to do. I think we do before. This one 11 looks like a 10 years use question. Okay. So you say it's 1, 2, 1, 1. Okay. So there'll be 1 magnesium here, 1 magnesium here. Okay. Mg. Then oxygen cannot. So this one there's 2 of them here. NO3 settled. Then 2 hydrogen here, 2 hydrogen here. Yeah, next one. At least do 12. Mixture of element. Mixture of elements. This is compounds. This is element. This is compound and element. Then this is element plus element.
Yes, element.
Correct. YD. So there are 3 methods of salt preparation, which is 1 is titration, then 2 is the excess method, then the third one is precipitation. So we have these 3. So how we decide whether a certain salt uses which method is via the flow chart. Say we have the salt to prepare. So I look at this. Then the first thing I decide is whether it's a soluble or insoluble salt. So if it's a soluble salt, yeah, so if it's yes, it's soluble. No, it is not soluble. So if it's soluble, right, then you go to another question, either titration or excess method. So in titration, you will have acid plus base, acid plus carbonate. Then if it's the excess method, then you will be acid plus base, acid plus carbonate, then 3 acid plus metal. The question here, right, is reactants, are the reactants soluble? So if it's no, there is excess method. Yes, there is titration. Then if the salt is insoluble, you straight away go to precipitation. Then in this case, it will just be 2 soluble solution containing the ions. Okay, so it's kind of like that. So this question here, right, is you start your decision very early. So that means you will plug, okay, say ammonium nitrate here. So you decide whether it is which method via whether it's soluble or insoluble. So this one, ammonium nitrate is a soluble salt. So you will land on this side. And just now you say titration uses spa salt. As in titration is for spa salts. So in this case, ammonium nitrate is using the titration method. B, barium sulfate. So is barium sulfate soluble or insoluble?
Soluble.
Then we have to go to solubility table. Solubility of salts is like this. All soluble and insoluble. We have this table. Then all nitrates are soluble. Then all chlorides are soluble except for lead, silver.
Means that which is correct.
Who is correct?
Insoluble. Silver chloride is insoluble.
Yeah, so it's
They say
precipitation.
They say cannot.
Precipitation.
I think
So
I read the question wrong.
maybe. Okay, so since we are here already, then carbonates, right? All carbonates are insoluble. Okay, all carbonates are insoluble. So carbonate is here. Then only left with sodium, potassium, ammonium. These are soluble. Then we have sulfates. Sulfates are on soluble side other than lead sulfate, barium sulfate, and calcium sulfate. So these are there's hydroxide also. Hydroxide behaves similarly to carbonate. So in that case, right, you see your B you chose is barium sulfate, you say, then that one is, this is insoluble. This is insoluble also. So that means this one is also precipitation. Then calcium carbonate is also insoluble based on whatever I written down here. So it's also precipitation. Then the silver chloride is also insoluble, so it's also precipitation. Then your answer should be A, this answer. 14. 2 minus, yep, correct. Yeah, Q has more protons than. Okay, what's wrong with statement A?
P and Q are metallic and
They can form.
covalent compound can only be formed by non-metallic.
So that means they form
ionic.
So P and Q have the same number of valence electron, true. What's wrong with this? Which is the wrong word?
Same number, same is wrong.
Same is wrong. So this one should be different.
Different.
Okay, then part C, which part of the statement is wrong?
Q has more metallic character than P. It should be P has more metallic character than Q.
Yeah, okay. 16, 17. Which statement about R and S is not correct? R and S, you chose B. Why is it wrong?
Because it's not in the same period.
Okay. Then what's correct about A? R and S are gases like the same at room temperature and pressure. So R is fluorine,
Halogen.
so halogens. So fluorine, chlorine, so they're all gases. Okay, S is greenish in color, yes. Chlorine is greenish yellow in color. Then S is bigger than R, so the relative atomic mass is bigger. That is correct also. Okay. 17, 18. A solid substance is added to a beaker of acid and effervescence is observed. So effervescence is observed, that means a gas is produced. So they are asking you, out of these 4 reactants, which reactor will produce a gas? Okay, so the 2 reactions that produce gases, right, is acid plus metal, okay, salt and hydrogen gas, and acid plus carbonate is salt plus water plus carbon dioxide. So what you are supposed to take note is these 2 reactions and that produce gases. So you have A, you crossed out because copper don't react with acids, that you are correct. Then base plus acid give you salt and water. This one doesn't produce gas. So you left with these 2. Then sulfate does not react with acid to produce gas. So this one out because this is a salt and acids don't react. So you're left with B. Then 18, I think you may have read it wrongly. Read it wrongly or you misread. Which statement about the property of all metal is correct? See, so what about gold? Is it a metal? Gold is a metal and it's not silver or gray in color. So what I do for such question is they say which statement about the property of all metals is correct. I would think about whether there are statements that are any metals that can fall out of the criteria. So like I say all metals are silver or gray in color, then I will start thinking about whether there is any metal that is not silver and gray in color. So then I found one. So then that means that statement is wrong. Copper is also, okay, copper metal is also not silver and gray. So that is another metal that falls out of that criteria.
Is pink color.
Yeah, copper is pink or red brown color. So be out, strike out. Then you say all metals can react with dilute acid. So I think about some metals that do not react with acid. So you see, copper doesn't. Copper, silver, gold doesn't react with dilute acid. So these are also gone out. Then all metals have high melting point and okay. So group 1 metals have low melting point. So because of that, this is also out. Answer A. All metals are good conductors of heat because they have mobile electrons. During the process of conduction, these electrons will move and then help to conduct heat at a faster rate from physics. But of course, if you don't take physics, you will not have that fact in your head, but it does not interfere with you scoring for that question because you can use elimination to get rid of B, C, and it's an alloy of 85% aluminum and 15% magnesium. Conducts electricity. Less dense than aluminum. Less dense than aluminum is important for aircraft because aircraft bodies have to be light. So it is stronger than aluminum or magnesium, yes, because it needs to withstand high pressure and also other harsh conditions outside when it flies. Then surface of the alloy is covered by a layer of aluminum oxide. This is required because then it tells us that it is able to withstand corrosion from all the harsh elements. So answer correct. Okay, last one. This one simply pick the least reactive because less reactive, the more reactive metals cannot be obtained heating the oxide with carbon. Can. Question 1 is all right, totally fine. Question 2, we need the drawing, so I have to reduce it. Okay, question 2B part 1. Which alcohol will distill over first? Explain your answer. Are you familiar with how fractional distillation works?
Yeah.
How does it work?
The one with the lowest boiling point will distill over first.
Because we need to heat the mixture, right? So when we heat the mixture, temperature goes from lowest to highest. So it goes from low to high. So it will reach a low temperature first. So the alcohol or the fraction that has the lowest boiling point will distill over first. Okay, so you know that fact. Because of that, right? Then they say which alcohol will distill over first. So you will pick the lowest boiling point, which is methanol. So you say methanol will distill over first. Second part, you explain the answer. So then you say that because it has the lowest boiling point out of that three. So that's how you get the answer from part 1. That's how you get this thing here. Then part 2. Part 2 here, they say describe the movement and you miss out something again. So they say describe the movement. What is describe and arrangement of particles of butanol at 100. So butanol is here. So it is like that. So below melting point is solid, then above boiling point is gas, in between is liquid. So you identify 100 is over here, that means it's a liquid state. So you are supposed to describe liquid state. I'm sure you got it because you kind of described correctly. So they say, so you have to describe the movement and arrangement. So you say the movement is slide over each other. Yes. Then your arrangement is disorderly manner, and then you forgot that because it's liquid, right? The particles are also close to each other. That's how you lost something there. Okay, all right?
Yeah.
Okay, so the table below shows some salts commonly found in fertilizer and the reactants used to produce these salts. Okay, so this is a preparation of salts question. Then remember the MCQ just now, then I was talking about how to prepare salts and what method to use. Yep. So ammonium phosphate is soluble or insoluble? Is it soluble or insoluble?
Insoluble.
All spa salts are soluble. So ammonium is soluble. So this is soluble. Potassium sulfate is soluble. Calcium nitrate is soluble. So when it's that means all soluble, that means you use titration. Then if it's titration, then you will be using acid plus base, acid plus carbonate. You don't use acid plus metal because metals is in solid form. So titration process, you cannot have a solid form. That's one. Two is you have to examine whether the metal has any intrinsic characteristics, like whether it is super reactive with water or is super unreactive with water or super unreactive or super reactive with acid. That's the other thing that you need to check. So because ammonium phosphate is soluble in water, we will use acid plus base or acid plus carbonate. So if you use ammonium carbonate here, you also be correct. Ammonium hydroxide is also correct. But ammonium nitrate is wrong because you cannot use a salt to react with acid. You caught that?
Yeah.
Then part 2, they say explain why potassium metal cannot be used instead of potassium carbonate to produce potassium sulfate. Then you say it will not produce the correct products. I'm sorry, it does produce the correct product because potassium metal plus acid, what was the acid? Sulfuric acid, it become potassium sulfate plus hydrogen gas. You will get potassium sulfate, but there's another reason why you don't use potassium metal.
Because it's too reactive.
Yes, so it's very reactive with water and very reactive with acid. So for safety reason, you won't use it because it is explosive. So when it explodes, you will not get anything that all the product that you want that is formed, right, will not be collected. It probably went somewhere else and then it caused a ton of hazard to the person in the lab or the person who's preparing that. So that's why you see your answer that they say potassium metal is too reactive and it will react explosively with acid, making it dangerous.
Why the teacher underline the colorizers?
Which one?
For the
This
question
one.
B. Yeah.
Question B.
Underline the colorizers and still gave me the mark.
Decolorizers, that means the magnesium caused the blue color in copper sulfate to disappear.
And why the teacher still gave me the mark?
But magnesium react with copper sulfate, the color or the blue color really disappears.
Means there's already no color.
Yeah, but we don't really use decolorizers for this kind of reaction. The word this keyword, right, decolorizers, is usually used for organic chem, the bromine plus alkane reaction. But it's not wrong. The observation is correct.
So that's why he still gave me the mark.
The observation is correct, so she has to give you.
The observation is correct.
Yeah, because copper sulfate does decolorize. So it's state 1 observation. But they might be expecting, say, a red-brown precipitate is observed because magnesium will displace copper from copper sulfate. So the magnesium dissolves and the copper metal appears. So there will be red-brown precipitates or deposits at the bottom of the flask or something. And of course, because you see, you wrote this here, so magnesium reacts with copper sulfate. So it becomes magnesium sulfate and copper. So this is actually colorless. This is blue. So magnesium does cause the blue copper sulfate solution to decolorize and become magnesium sulfate. Then red, brown, PPT, silver. See the color observation. Okay, yeah. Okay, so the airbags used as a safety feature in the car contains the compound blah blah blah. Upon impact, this powder will decompose to produce lumps of sodium, metal, and nitrogen gas, which inflates the airbag. The reaction is represented in a chemical equation below. So you will have to fill this for me, even though you're not required to do it in the test.
Why have bracket?
Okay, so the line here, so you didn't do because why got bracket there? So this is the balancing the number. This one is the state symbol. So the state symbol is in the bracket. 31.
3.
3. Okay, all 3, the one. So upon impact, the powder, that means it's solid, then becomes a gas and to produce solid sodium metal, lumps of sodium metal like that. State symbols, okay. Okay, then you decided on the numbers? Why you delete the answer correct? Solid there. So you have 6 nitrogen. Yeah, correct. Then the second part, show the dot and cross diagram, only valence electron for nitrogen. So first we must know that nitrogen is in group 5. So it has 5 valence electrons. after the bonding, then it will be every one of them should have 8 valence electrons. Okay, so I go to your answer, then I will cover this part. So it's a dot and cross diagram, so you have to one dot and one cross. So I can't exactly see which ones are dots and which ones crosses here. So how many dots and how many crosses are there?
One dot, one cross.
One dot, one cross. So that means there are 2 electrons here. In this section, there are 2 electrons, one dot, one cross, right?
Yeah.
So if that's the case, there's one dot, one cross here. So there's two electrons here in this middle section, plus 1, 2, 3, 4. So nitrogen only has 6 electrons, but after bonding, then they must achieve a stable octet structure. So both of them must have 8 electrons. So nitrogen on the left has only 6 electrons. That means the answer is not correct. Okay?
Yeah.
So that means the number of electrons shared, right, is not one pair. It's probably more than one pair.
Two pairs.
If it's 2 pairs, it will be 3 electrons here and 4 electrons inside.
Then 7.
Also salah, wrong. So then you try 3 pairs. So if it's 3 pairs, that means out here will be 2 electrons and inside here will be 6 electrons.
8.
Then correct, yeah. So your answer will be like that. 6 electrons here, dot, dot, that. Okay? So you will have to write. Sodium azide is NaN3. Then they say nitrogen gas. So in terms of bonding and structure, explain why nitrogen has lower boiling point than the other one. We'll let you write, then we'll continue. 3 marks, at least 3 points. So you say sodium azide has an ionic bonding. It's an ionic compound that has strong electrostatic forces between ions. Okay. Then this one. Okay, so this format is correct. This part 1, 2, 3, 4. This is okay. This is good. So do you have the same for nitrogen?
Nitrogen has weaker intermolecular forces of attraction.
It's simple
covalent bond.
Compound.
Covalent compound.
With weak intermolecular forces of attraction between molecules. So this, and then, so you see, then your format for nitrogen and sodium is the same. So then, therefore, nitrogen, here, right, this part, nitrogen requires less energy. Yeah. Or let's say not like this. I think rephrasing it. Let me rephrase this. Less energy is required to overcome the forces of attraction between molecules of nitrogen. Therefore, nitrogen has a lower BP than. Does it look more complete like that?
Yeah.
You are getting there much better than before. So yeah, continue to work on it. You will get a even better answer next time. Okay, you want to take down?
Done.
Okay, NaN3 becomes Na plus nitrogen gases 3, 2, 2, like that. So they say determine the relative formula mass of sodium azide. So how do you find relative formula mass?
What is relative formula mass?
Relative formula mass is relative molecular mass. Relative formula mass is the name for ionic compounds. Then relative molecular mass is for covalent compounds. If you go to my slides long time ago, you will see this. It's written there. Okay, so periodic table says that the mass number for, you use mass number, you do not use proton numbers. So the periodic table says that the mass number for sodium, right, is 23. Nitrogen is 14. You use mass number to calculate. So sodium azide is NaN3. So the relative formula mass is 23 plus 14 times 3.
65.
Yeah, 65. Then calculate the mass of, number of moles is mass over molar mass. So it's mass over 65 times 0.2 grams. Okay?
Yeah.
Question 6, you have magnesium chloride. So magnesium chloride is group 2. Magnesium chloride is group, yeah, like this, right? So it becomes this and like that. So that means this one has lost 2 electrons in the valence shells. So you didn't draw the valence shell already. So then you lost 2, then you forgot about this. Right. Yeah. Then the electron is transferred over here. This is correct. Then you have 2 of those chloride ions. So yeah. Then part B here, I think you just forgot to balance. You forgot to balance, right? Because the others are also not, there's no coefficients here. So they write here on, that means you forgot to balance. Yeah, so that is, I forgot. Then the not so nice ones are probably the structured question here. Down here, right, is a very big word called describe. Okay, so you tried, you missed out a bit. This step, describe the steps involved in preparing a pure and dry sample of magnesium chloride salt after mixing magnesium metal and dilute hydrochloric acid. So after mixing, what will you have? You filter because there is a mixture of magnesium chloride and magnesium metal. So this one okay. Then evaporate the excess liquid. What is this liquid? Evaporate the excess liquid until saturated. So let's filter the mixture and then evaporate the filtrate until evaporate the filtrate until saturated solution is formed. Then you are still missing some stuff. Before your filter press and dry, right, you should have another step. What is the step? So number 1 is filter the mixture, then to evaporate the filtrate until it, then 3, or you can say heat the filtrate to remove until a saturation solution is formed, like that. Then before your filter and press dry, there's one more step. And after your saturated solution is formed, you need to cool the saturated solution. Then until crystals precipitate. Then you filter and press filter to collect the crystals and that. You are missing this one. So you must take note that one. Okay? Okay? Okay, so D, right? It's like this. They say in terms of their composition. Composition means what makes up the substance. So then it say explain dry sample of magnesium chloride salt, and then the other one is magnesium chloride solution. So we will go to how you get your magnesium chloride salt. That means what you did was you went through the whole process, you filter, then after that, then you have a solution that is this one. Then after the solution, what you do was you evaporate the solution until it becomes saturated. Then after that, then you get the salt. So that means, right, the final salt, right, you get is actually just magnesium chloride crystals. That is the dry sample. Then the solution comes in the form of a beaker. So you have magnesium chloride inside. You also have water inside. If it's a solution, there will always be water. A solution always contains water. So this is the magnesium chloride solution. That's one thing to note. Then the second thing to note is you need to know the definition of what is a compound and what is a mixture, right?
Yeah.
So then you have your teacher gave you a bunch of notes I saw, so I will not add more notes to you. So one is they say compounds here, they have a fixed composition. Fixed composition means that if the compound is made up of 2 elements in the ratio of 1:2, then if you go to any other magnesium chloride compound, that in this case, right, the ratio will still be 1:2. Then you can, whereas a mixture, the ratio is always different. So in this case, right, magnesium chloride is this. This contains only one magnesium chloride crystal. Whereas magnesium chloride solution, right, it contains magnesium chloride and water. So then the proportion of water and magnesium chloride, right, can always be different. You can have sometimes more magnesium chloride and less water, or sometimes you have more water and less magnesium chloride. So the ratio of composition in magnesium chloride solution is not the same all the time. So then the second case where they talk about fixed melting and boiling point, what happened is like this. If you have a compound, then the melting point and boiling point doesn't change. So if you have say water, right, pure water, the boiling point is always 100 and the melting point is always 0. But in the case of magnesium chloride solution, right, what happened is if there is a lot of water, then when you boil and measure the boiling and melting point, right, what you're measuring is the boiling and melting point of water, and the melting boiling point will be different from the melting and boiling point of pure water. Then you would not be able to boil and melt magnesium chloride solution unless you evaporate all the water, because the magnesium chloride, the melting and boiling point is very high because it's an ionic compound. So either way, when you measure the melting boiling point of either water or magnesium chloride, right, a solution, the melting boiling point will always be different depending on how much water and how much magnesium chloride you have. So it's a mixture. Then a compound, the properties will always be the same. So magnesium chloride is always the same color. Crystals, it will be a solid, and then it's colorless. So for magnesium chloride, it may not be the same case because of the addition of water, that no longer become a solid mixture. Then in that case, right, then you have to, if you were to take the magnesium chloride, right, then you can separate it physically, then by your filtration and all that. Then after that, then you come back, then you'll get what the properties of water on its own, and then you'll get the properties of magnesium chloride on its own again. So we should come up with a table that is clearer to do the compound and mixture. But anyways, if you look at your answers, right, then you see that they say that magnesium chloride is in a fixed proportion by mass of magnesium and chlorine. Then magnesium chloride solution, then the magnesium chloride solution, right, it is not the same because your composition of water and magnesium chloride is not in a fixed proportion. Okay. Your group 7 question is kind of fine. I mean, you have a very good attempt at question A. Then your question C also is a very good attempt there. Then you forgot to balance the equation again. Cannot really see. KF and Cl2. KF is not a liquid. KF is not a liquid because up here, right, you already have it as a solution. KCl is a solution. So KF will behave like KCl. It will also be a solution, so it becomes equals. So down here, that's why this one is also equals. Then after that, you never balance. Then this one, they are saying that it is dissolved in water. Okay, I think the biggest thing is you never balance. Okay, this one, 2, this D, explain the difference. Explain the differences in reactivities between fluorine and neon with reference to their electronic configuration. Here, right, because they say with reference to their electronic configuration, so you should write out the electronic configuration. So fluorine is how much? 27. Then neon is do you have a periodic table? Okay, fluorine is 9 and neon is 10. So neon is, this is fluorine is 27, then this is 28. So with that, so you have the electronic configuration already, then you can start saying that fluorine has 7 valence electrons. So it will gain or lose electrons to achieve the stable electronic configuration. Then you see your J, right, does not have a noble gas structure because she asked you to elaborate, he asked you to elaborate because you did not write this. Then you say neon is unreactive as it has a noble gas structure, this one. So you're lacking on this part. Okay? So this is the end.